Hi everybody. We are going to discuss about the embedded operating system modeling. In fact, the IO systems, that's input-output subsystem we can see in the embedded technologies. So mainly, the embedded system is specialized computing systems to design the performance and operations that are in the larger system, because it's embedded or combined the many systems, many components. So it comes under the embedded technologies, larger systems. They are typically built into a dedicated and a particular hardware, often with real-time computing constraints. And there are preventing the various applications, including the consumer electronics, automotive systems, industrial mechanisms, machines, medical devices, and more. So we can incorporate, we can add a n number of devices in the medical field, automotive field, electronics, military, embedded operating systems, and consumer electronics that we can use. And examples, the IoT devices, automotive systems, and the consumer electronics we can use is the main important parameter in production systems. And the IO system is a very important parameter. Any system you can take, the IO system is very important. The user interface and device independent IO devices are main important parameter. The device driver, mainly we are used as a key kernel users, and we can able to do the hardware technologies. We can interconnect the user and the external interface and the hardware. These three we can interlink. Under the device controller and USB devices, we are used in the main parameter we can use for the IO subsystem mechanisms. And the main components we are using the processor interfaces, peripheral controllers, device derived drivers, and interrupt handling mechanisms, and IO controlling logic buses and IO benefits catches are we can use. In the communication protocols, we have the inter-systems protocol, that is USB, UART, and ESRT we can use. In the intra-systems protocols, that's I2C, the SPA, and the CAN we can use for the communication protocols mainly. And real-world examples, the automotive systems, home applications, consumer electronics, healthcare devices, aerospace, and Internet of Things, and energy management, and it goes on. We can use a number of applications, and the main real-world examples we can use is embedded technologies here. The output subsystem, mainly the output refers to the hardware and the software components and responsible for delivering the information signals to the external devices and the users. We already seen the IoT and the real-time uses and all we can use it in the day-to-day life. And consumer electronics, military applications we are already using that. The various output devices such as a display, actuators, and audio devices, and communication interfaces we can use as a subsystem. That output subsystems mainly we can use. The process, the data received in the subsystems is processing or unit and other interrupt process or presence in a usable format and fulfill the specific requirements or the user interactions mainly we can use. And it plays a crucial role and conveying the information to provide the feedback about the controlling the external process and the embedded systems and across the wide range of applications. Is the important output systems we can use, because it will be interconnect in the real parameter and the inbuilt parameter. So it is very important thing we can use. And the design, mainly the embedded system having some constraints and consideration in the designing is power consumption and the size, performance, cost, environment, users experience, and regularity, and the interfaces. This some few important parameters we can use. And the power consumption, mainly the important key aspects we can use the power management methodologies and power management technique. Size constraints, because based on the size it will be modifying or varying the power consumptions. And the performance requirements, every systems need a performance requirement. Based on the performance requirements only it will perform or it will succeed in the market. And the cost also very important parameter. Cost effective is very important, and environmental conditions, user experience, all the it's important key parameter for the design. Based on the design only, every product and every real-time usage will be in consider and success in the market. And output generation process, mainly the systems that refers to the sequence and the step involved in the productivity and delivering the meaningful output in the external devices and the user-based output data, and also including interrupting the data, formatting the target output devices, interfacing the appropriate output signals in the signal action to prevent the feedback user in the external systems. The output generation is mainly actively used in the processed information, and also the actual output parameter we can use in the main parameter ensuring that the embedded system to fulfill the interacted or indented functions users require in the output generation process mainly. The trends we have mainly trends and development in that the sensor functions and multi-modal input and haptic feedback and gesture recognition and the natural users and wireless connectivity and IoT interaction. These are the important parameters. And the feedback and the sensor fusion multifunction input and wireless connectivity. These are the important parameters we can use for the communication technologies. Thank you.